If you don't use Desmos, if you prefer to use GeoGebra, then there is GeoGebra is also available as an option in here. You can also do your geometry in the same way. I could get Michael to draw a line in very easily, and he's creating another line. Under the More here button, we can see that he could create a perpendicular line or a perpendicular bisector. So if you clicked A and B, then the perpendicular bisector has been made between those 2 points. Again, we can measure our angles if we wanted it to. And Michael is also drawing on it to demonstrate. So it's very interactive. You can measure your angles and your areas in here. So that tells you the angle, and again you can move it. So you just would need to come down to the arrow. So if you click on the arrow at the bottom, you can move D around and it shows you the angle changing. So students can really find this interactive if you prefer it to Desmos. Both of them also have a graphing situation. So GeoGebra is all within the same thing. If you're looking for the Desmos graphing calculator, it's up here as a separate tab, but you can do the same thing on either of these. So if I wanted to draw the graph of y equals x squared, I can do that. I can see that it's there. I can move it around. Y equals x. Let's make this x minus 2 squared. So what can you see has happened there, Michael, with the two graphs? If the green one there is x squared, if I've done x minus 2 squared, what's happened to the graph?
The intersecting point.
Yeah, the turning point.
Yeah, the turning point.
Yeah. In fact, the whole graph has moved, but we can clearly see it at the turning point. If I did x squared plus 4, for example, can we see what's happened to the red one there? Just make it y equals.
It went up.
It went up. So can we see that if we do something inside the function, inside the squared, it has resulted in moving on the x-axis. And if we do something on the outside the squared, so we've done the x squared first and then added it, it's moved us on the y-axis on that one. So very clearly demonstrating to students, and students can see that our graph transformations move things around. So we've got options within the calculator suite to be able to do this. The equations can get pretty fun. We can add in some trigonometry if we wanted to. So that's just sketched the graph of sine x, and what it has always also given us is the values of intersections. So if I was doing an A-level question on intersection of graphs, then I could find my answer on here and demonstrate it both algebraically and mathematically. So algebraically and graphically on the calculator and on the graph to be able to see those answers. So you can really get to exploring graphs using the graphing software, get students to do things with them.